Let's find a complete factorization of this function. I'm going to, since it's a fourth degree, I'm going to assume I can't do too much with it. I'll take a quick look at the graph and see if that will help me. Hey, that looks pretty good. There seems to be a 0 right there at 2. So let's use some synthetic division to find out if that actually is a 0. So I'm going to put 2 in there as my 0, and then remember I've got just my coefficients. Why do I always do that? I don't need that plus sign anymore. 38, negative 64, and 40. Okay, so let's get started on the long division, or the synthetic division here. As soon as I erase that thing. Doesn't want to erase. Okay, never mind. Get out of the way. Alright, here we go. My synthetic division. Bring down the 1. And remember how this works. I've got 2 times 1. I put that product here. That is 2. And then I take negative 10 plus 2. I put that sum here. That's 8. And then I take 2 times 8. And I put that product here. That's 16. And I made a mistake. This should be negative 8, so this should be negative 16. Now, when I add 38 and negative 16, I get 22. When I multiply 2 times 22, I get 44. When I add 64 and 44, I get negative 20. And finally, when I multiply 2 times negative 20, I get negative 40. Adding up the last column, I get a 0 remainder. 0 remainder, that's good news. That means that I did find a 0, and it is 2. Now, what's my new quotient? X cubed minus 8x squared plus 22x minus 20. Still not a quadratic. It might be useful to graph this one too. Okay, there we go. You can see we have another candidate for a 0. That looks like there's a 0 at 2. That would be the second 0 of 2, so that 0 would have a multiplicity of 2. Okay, get out of the way, and what we're going to do is a little bit more synthetic division. We're going to check 2. As I said, we're going to check 2 as a 0 of 1, minus 8, 22, minus 20. Okay, scoot this up, and here we go, synthetic division to the rescue. Bring down the 1. 2 times 1 is 2. Negative 8 plus 2 is negative 6. 2 times negative 6 is negative 12. 22 plus negative 12 is 10. 2 times 10 is 20. And negative 20 plus 20 is 0. Bing, 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 bing. A remainder of 0. That means that 2, again, is a 0. 2 is a 0 of this polynomial here. So, what is my next polynomial that I'm working with? Now I've gone from a quartic to a cubic. I'm down to a quadratic, x squared minus 6x plus 10. And I can take a quick look at this and recognize that it is not factorable. Let's throw the whole thing into the quadratic formula. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. All right. My a is 1. My b is negative 6. And my c is 10. I'm going to start substituting x equals the opposite of negative 6 plus or minus the square root of negative 6 squared minus 4 times 1 times 10 all over 2 times 1. X equals 6 plus or minus the square root of 36 minus 40 over 2. X equals 6 plus or minus root negative 4 all over 2. This is starting to look like 6 plus or minus 2i all over 2, which is 3 plus or minus I. So there are the last two roots. And that means that my roots are 2, 3 plus I, 3 minus I. Notice 4 roots, exactly what you would expect from the fundamental theorem of algebra. Okay, let's write this function out as a fully factored, whoa, what the heck just happened? As a fully factored polynomial y equals x minus 2 times x minus 2 times x minus the quantity 3 plus I times x minus the quantity 3 minus I. A little bit of distribution over there on the right to clean things up. X minus 3 minus I, x minus 3 plus I. And there you go. You have fully factored that friggin' function, right? Yay, good job. Okay.